we're going to go through two more examples. This one we're going to find the area between the two curves. It wants us to find the area between the cube root of 2x and y equals 1/8 x squared. Between 0 and 6. So this time they gave us, just like the very first example, they gave us our limits of integration. We want to go from x equals 0 to x equals 6. So let's go ahead and sketch these functions to see where the upper function is and where the lower function is. Now this one I'm going to do in red. It's a cube root graph, so it looks something like that. And then we've got the 1/8 x squared graph, which looks something like that. So we want the area bounded between the two curves from 0 to 6. So that's all of this area and all of this area right there. So this is like our case 3 with the areas. We've got an upper curve and a lower curve, and then we've got a point. We can call this point C. Call that point C. We need to find that intersection point, because what we're going to do is we're going to break the integral up into two separate integrals. One integral going from 0 to C, upper curve minus lower curve. The other integral from C to 6, upper curve minus lower curve. So let's first find our C value. All that means is take the two equations and set them equal to each other. I don't want the fraction there, so what I'm going to do is I'm going to multiply both sides by 8. And you get 8 cube root of 2x is equal to x squared. Not only that, I don't want this cube root, so I'm going to cube everything. So 8 cubed is 512 times the cube root of 2x cubed. The cube root and the cube cancel is equal to x to the 6th. So you get 1024x is equal to x to the 6th. And then what I'm going to come over here and do, I'm going to erase this. I'm going to subtract this over. So I got 0 is equal to x to the 6th minus 1024x. I'm going to factor out an x. I get x to the 5th minus 1024. And then you set each piece equal to each other. So x equals 0 from this one. And then from this one, you get x is equal to the 5th root of 1024, which has a nice whole number answer. It's equal to 4. Okay, so my C value is equal to 4. Now on my graph, it doesn't land exactly on 4. That's because I freehanded it. If you look on the calculator, you definitely see it equals 4. So now we know what C is equal to. We no longer need this. No longer need that. Now we can write our integrals. So the first integral is going to be from 0 to 4. Now we're going to do the upper function minus the lower function. The red function, cube root of 2x, minus the lower function, 1/8 x squared dx, plus the integral from 4 to 6. Now they switch roles here. When you do the absolute value, another way to take care of the absolute value is to switch their roles. Make the other function the upper function, make the lower function the other function. What we could do here is absolute value of the same thing, or we could switch them. So now the 1/8 x squared is the upper function minus the cube root of 2x, that's the lower function, dx. So this will give us this first area. This will give us the second area right there. So we no longer need the pictures or the original functions. We have our integrals. Once we compute the antiderivative here, doing this one is very easy because it's the same thing, just they're switched. So integrating this, you're going to have a chain rule here that you have to undo. You got to use the 5.5 to do this. You're going to let u equal 2x. du is going to equal 2dx. So when you solve for dx, you're going to get 1/2 du. And then it turns into a power rule, and that's only for this term here. You don't do it to here. Then you undo the power rule in terms of the u, and I'm just going to give you the answer. You get 3/8 times 2x to the 4/3 power minus, undo the power rule on here. You get a 1/24 because you go up 1 power to get x cubed, then you divide by that 3. 1/8 divided by 3 is 1/24. Evaluated from 0 to 4 plus, and now the antiderivatives are exactly the same thing. We just got to switch them. So I'll put a parenthesis here. It's 1/24 x cubed minus 3/8 2x to the 4/3 evaluated from 4 to 6. So now all you have to do is plug 4 in, plug 6 in. I would use your calculator for this. This is a lot of plugging in, evaluating numbers. I'll write it out, the numbers when we plug them in. But then, like I said, after that, use the calculator. 3/8, I want to plug 4 into here. If I plug 4 into here, 2 times 4 gives me an 8 to the 4/3 power minus 1/24, 4 to the 3rd power. So that was just evaluating the antiderivative at the upper bound. Minus, if I evaluate the antiderivative at the lower bound, I get 0. That was that first integral. Here's the upper. Right there is the lower bound. So upper minus lower. Plus 1/24, the upper, which is 6 cubed, minus 3/8. If I plug 6 into here, 2 times 6 is 12 to the 4/3 power. So here's the upper bound estimate. Upper minus, now here's the lower bound estimate. I got to plug in 4. 1/24, 4 cubed minus 3/8 times 8 to the 4/3 power. So close parenthesis and close bracket. And right here, that's the lower endpoint. So I plugged 4, and that gave me my upper limit evaluation for this integral, our first integral. Then I plug in 0, you get 0. Then for this one, I plug in 6, and that's where this is coming from. Minus, I plug in 4, there's my lower estimate. Now, if you were to punch this on the calculator, you get about 5.36. That would be the area, okay? 5.36. Enclosed between both curves. So now let's do our last example. Our last